Swayam Prabha. Digital India. Educated India.
Welcome to the lecture on data visualization using Ggplot. In this lecture, we are going to see how to generate a scatter plot using the package Ggplot 2. We will also see how to generate simple scatter plots, and we'll see how to change the color, shape and size of the points used in a scatter plot. In addition to this, we will also see how to introduce more variables in a scatter plot. So to generate scatter plots in this lecture, we are going to be taking a data that's called HR analytics. Now the total size of this data is 14,999 by 10, which means there are 14,999 rows and 10 columns. The data file goes by the title peoplecharmcase.csv. Now let's look at the variable description. The variable satisfactory level is the score given by the employee to the employer. It's a continuous variable with the range between 0 to 1. The variable last evaluation is the last evaluation score given by the employer to the employee. This is again a continuous variable with the range 0 to 1. The number of projects basically tells us on how many projects has a particular employee worked on. Now this is an integer variable. The variable average monthly hours tells us the average hours spent by an employee in a particular month. Now this is a continuous variable and the units are hours. The variable time spent dot company tells us how many years has a particular employee spent with the company. The variable work accident tells us whether a particular employee met with an accident while he or she was employed with the company. If they met with a work accident, this variable takes a value 1, otherwise 0. The variable left denotes if a particular employee is about to leave or has already left. Now if they've left, the variable takes a value 1, otherwise 0. Variable promotion in last 5 years tells us whether a particular employee was promoted in the last 5 years. 1 if they have been promoted, 0 otherwise. The variable department tells us the department to which a particular employee belongs to, and the variable salary tells us in which salary bar does a particular employee belong to. Now there are 3 categories to this. One is high, the other is medium, and the third category is low. So this was the variable description for this data. So now let's see how to read this data. So I need to import the data into R. Like I earlier said, peoplecharmcase.csv is a CSV file. So to load this data, we need to use the function read.csv, and this function will basically read a file in table format and it will create a data frame from it. So I'm using the function read.csv. And within quotes, I am mentioning the name of the file, which is peoplecharmcase.csv, and I am saving the output that is generated by this function into a variable called HR. Now once you run the function, a data frame is created and saved onto the variable HR. So HR becomes the data frame and you will see that this gets reflected in the environment. So like I said, a data frame with the name HR is created. You can see that there are 14,999 observations. So you have 14,999 records and 10 columns. So below you can see that there's a small snippet of how the data frame looks like. So you have all the variables. I have given a snippet of only the first few rows, keeping the space constraint in mind, but you will actually see all the rows when you open this data frame. So you basically need to click on this data frame and you will see a small window pop up with a table that's same as what I've mentioned here. You will see more rows to that table, but I have given you only a gist of the first few rows. So let's now look at the structure of the data. So the structure of the data basically tells me what are the variables involved and what is their data type, and if they are categorical variable, then what are the number of categories which are given under that specific variable. So to find out the structure of the data, we are going to use the function str, and within parentheses I am just giving the name of the data frame. The name of my data frame is HR. Now once I execute this function, you will see the corresponding output that I've shown below. Now this basically tells us that HR is a data frame with 14,999 observations and 10 variables that are the number of rows and columns respectively. Also on the left, you'll see that all the variables have been mentioned, and in the next column you will see their data types mentioned. And what you see after that are the first few values in every given column. For the last two variables, that is department and salary, it says that it's a factor. Factor it actually means categorical variable, and with 10 levels. So W / denotes width and 10 levels and 3 levels respectively. So levels basically denote the number of categories inside each variable. So department basically is a categorical variable with 10 categories, whereas salary is a categorical variable with 3 categories. So this is what it means when you say levels. So you will also see the first few levels, which are accounting and HR under department, whereas the 3 levels in salary are high, low and medium. So one thing that you have to notice is that all levels are alphabetically ordered. The other thing that you need to notice is that some of the variables have been read as integers. So let's see which are the variables that have been read as integer. So there's only a defined number of projects in this data. So hence number of projects should actually be categorical. Here it's read as a qualitative integer because it's basically a category. So we have to change number of projects from integer to category. The next is time spent in the company. Again the same applies here. The number of integer values under this column is limited, and hence they have to be treated as categories. The variable work accident has a value 0 or 1, and hence it has been read as an integer. Again this has to be converted to a categorical variable. So similarly the variable left and promotion in last 5 years also take a value of 0 and 1, and hence they've been read as an integer, and we need to convert them to categories. So now let's see how to convert these variables into the required data type. So I'm now going to first convert number of projects to a factor. You have to remember that whenever I use the data type factor, it actually is used for categorical variable. Number of projects is an integer variable, so I'm converting it to a categorical variable using the function as.factor. So what I have to do is I just have to access the variable number of projects from HR. So to access the variable number of projects, you can use a dollar symbol. So whenever I say HR dollar number of projects, this is a way of accessing the variable from a given data frame HR. Now to convert it to a factor, I am going to use the function as.factor, and again I am going to give the same variable name inside the parenthesis. So this is how I convert integer variable to factor variable. So similarly, we are going to do the same step for the variable time spent company, work accident, left and promotion in last 5 years. So you can see that all these 5 variables have been converted to categorical variables using the function as.factor. Now if you would like to check whether these have been converted or not into the desired data type, then you can run the function str again and give this data frame, and you will see an updated data type for all these variables. So let's see how to install the ggplot package before we generate a scatter plot. Now what you need to do is you need to go to the packages tab and then click on this icon install. Once you click on the icon install, you will see a small pop-up like the one mentioned here, and it's called install packages. That will be the title of the pop-up, and you need to mention the name of the packages. So one good advantage is that the moment you start typing the name of the package, you will see a couple of suggestions below. So you can choose a correct package from here and install, and you need to tick against install dependencies. So any dependent package that's required for ggplot to be installed, that also gets installed automatically. So once you enter ggplot2, you will see a couple of suggestions is thrown, and you can just choose the correct option, which is the first one here like I've shown, and then you can just click on the button install. Now this takes a while, this takes a few minutes, and once it's done, then you can use the ggplot function. So now let's see how to generate a scatter plot. But before we go on and generate a scatter plot, let's understand first what a scatter plot does. So a scatter plot uses Cartesian coordinates to plot values for 2 numerical variables. So what you see here is an example of a scatter plot. Now this was generated using the data set that we've read, and as we go further, we'll also learn how to generate this simple scatter plot. Now here you can see that the x-axis has satisfactory level, as one of the variables, and the y-axis has last evaluation as one of the variables. And like I earlier said in the variable description, both these values are numerical values, they are continuous values, and hence we can use a scatter plot for them. Now we can also introduce a third and a fourth variable in this simple scatter plot, and this we can do by encoding them using a different color, shape or size. Now it is necessary that the third and the fourth variable that you introduce have to be categorical variable. They cannot be continuous variable or an integer, but they have to be a categorical variable. The main purpose of using a scatter plot is actually to understand what is the underlying relationship between the two numerical variables that I have used. So this can be inferred from a scatter plot. So now let's see how to generate a scatter plot. So to use all functions from Ggplot2, you need to first load the package Ggplot2 using the library function. Now we are going to generate a scatter plot, like I earlier said, between last evaluation versus satisfactory level. So we are going to use the function ggplot for this. First I am going to map the data and then the variables. So the data is basically the data frame here. The name of the data frame is HR and the parameter to which it's mapped is called data. So on the left you will see all the parameters of the function, and on the right you will see all the inputs that we are giving to the function. So data is already an inbuilt parameter, and here you need to supply your data frame. Now within this function you will also see another function called aesthetic, that's represented as AES, and within the parenthesis of this function I am specifying the x-axis. So under this I need to mention the variable that goes on the x-axis, and under the parameter y I need to mention the variable that goes on the y-axis. So I need to map my data and the aesthetics, which are the x and the y-axis, in this step. Now once you execute this command, you will see that only a grid is created. So you can go to the plots tab and you will see that a plain grid is created. Now in this grid you can see that the x-axis has the satisfactory level, the y-axis has the variable last evaluation. The grid is basically mapped till 1 on both axes, and that's because both these values, last evaluation and satisfactory level, both of them have a range from 0 to 1. Both of these are continuous variables and both of them have a range from 0 to 1. So this is just the first layer, and you can see that only a grid is created with a neatly labeled axis and the limits for both these axes. So the next step is to basically plot all the data points, and we are going to be using the function geom_point. So from here we are going to build layer by layer. The first layer is the grid. The next layer is going to be adding the function geom_point. So ggplot and the data and the x and the y axis, all that you've mapped in the earlier step is going to be the same. The only addition to this step is you need to add the function geom_point with the parenthesis. I've added a plus symbol here just to make sure that I am adding another layer. So once you run this, you will basically see a scatter plot that's similar to the one I have mentioned on the right, and this becomes the second layer, and you can see that the data points are mapped as black circles. So in ggplot, for a scatter plot, the default shape is circle and the default color is black. So you can see all the points are mapped as circles and in the color black. So now let's see how to change this color of the data points from black to blue. Now to change the color of the points, you can use the parameter call, and under call you just need to mention the color. Now I've given the color as blue, and this entire parameter and the value for it comes inside the function geom_point, and I've just highlighted this just to show you that this is the additional change that you have to make to the earlier code. The other parts of the code remain the same. So this part is highlighted just to show you that this was the only part that was changed compared to the earlier code. And once you execute this, you will get a plot that is similar to the one on the right. Now I have a small snippet of the plot here, and here you can see that all the black circles have been changed to blue. So I actually changed the color of these points. Now instead of changing the color of the points, I can also change the shape of the points. So let's see how to change the shape of these points to any other shape. So the shape of the points can actually be changed using the parameter shape. So the parameter is called shape, and under that you can mention a value. So there are two kinds of values that this parameter takes. One is an integer value, the range for this value is 0 to 25. So what you see here are just different numbers. So 0 corresponds to a square, 5 corresponds to a diamond, 10 corresponds to a circle with a plus inside, 15 corresponds to just a solid square without a border, and 22 corresponds to a solid square with a black outline and a fill inside. So these are the range of shapes that you have between 0 to 25, and you can check the website to know more about these shapes. There is a documentation given for this function. The other kind of value that the shape parameter takes is actually the name of the shape. So a circle is mentioned as the circle, an unfilled circle with an outline is called circle open, a filled circle is called circle filled, and then you have a small circle, you have a bullet, and then a circle with a plus sign is called circle plus, or a circle with a cross is called circle cross. So these are the various kinds of names that every shape has. Again, you can check the documentation on the website to know more on the naming convention or the integer values and the corresponding shapes to which they correspond to. So like I earlier said, circle is the default shape, and in terms of integer, the default shape number is 19, which corresponds to a circle again. So now let's see how to incorporate a different shape to this function. So now let's see how to incorporate the shape parameter. The shape parameter again goes inside the function geom_point, right? In the earlier slide, we just saw how to change the color. Now I'm switching the color back to black here, and I'm just mentioning black within quotes under the color parameter. The next parameter that I'm giving is the shape parameter. Now the value that I'm giving it is 22. Now 22 corresponds to a filled square where you have an outline for the square and there's a color inside. So whenever you use such kinds of shapes, then you need to mandatorily give a fill color. Now the fill color that I'm giving here is red, and that goes under the parameter fill. So the value I'm supplying is red, and that is the color that goes inside the square. So if you don't mention the fill color, the default color is white, so you will have an open square. So now let's see what is the output that we get once you run this command. So this is the kind of plot that will get generated. You have satisfactory level on X, last evaluation on Y, and you will see that because of the kind of shape that we've used, you will see that the points, that is the circles which are the default pointers, are replaced by square here. So this is how the output for the previous command will look like. So a couple of points to note is that the size of the filled part, that is the color inside each of these shapes, for the shape numbers 21 to 24 is basically governed by the parameter size. Now for other shape values, this parameter basically determines the size of the shape. So let's see what is the effect of size for this shape. So I have highlighted the extra parameter that you need to supply within the geom_point function. Everything else remains the same as seen in the earlier slide. So you have the same ggplot function. After a plus notation, you need to add the geom_point function, within which the color is retained as black. Again here, the shape, I'm using the same shape, which is 22, which is a filled rectangle, and the fill color is red. Now the only additional parameter that I'm giving here is size, for which I'm giving the value as 2.5. So let's see what is the output for this and what kind of a plot do we get. Here you can see that the sizes of these squares are bigger, and that's because of the size parameter. What you'll also see is that the area that's filled inside is bigger. So you'll not only see that the square is bigger, you can also see that the filled area is also bigger now compared to the earlier plot. So this is the output that you will get when you mention size for filled shapes compared to the unfilled shapes. So now let's see how to add a title and axis label to the scatter plot. Now for any plot, you need to mention the title and the axis labels, and that's because it gives a description to the plot. We need to understand what are the parameters that we are plotting on the x and the y axis, and what is the title. So there are two ways to add a title and axis label to a plot. One is using the labs function and the other is using the ggtitle. So let's see how to do it with each of these functions first. So first I'm going to take the labs function. So I again need to add a plus notation here, and I'm going to add the function labs. So within labs there are 3 parameters that you can give. So one is the title, which is the title of the plot. So I'm calling the title for my plot as last evaluation score versus satisfactory level. The next parameter is x, which tells you what is the description that should go on the x-axis. Now this is satisfactory level on the x-axis, and the parameter y basically tells us what should go on the y-axis. So on the y-axis I have last evaluation score. So within the labs function you can mention the title, the x label and the y label. Now let's say if you want to try it with the Ggtitle function. So what I'm going to do is I'm again going to add a plus notation here and use a function Ggtitle. Now this function will only take the title of the plot. Now I'm again using the same title, which is last evaluation score versus satisfactory level, and you need to give this within quotes again, and I'm using a plus notation here. Now the x label and the y label is basically given by the function xlab and ylab, which corresponds to x label and y label respectively. So within the xlab function I'm giving the description for the x label, which is satisfactory level, and I add a plus notation again here, and then I'm adding the y label, which is represented by the function ylab, and within the parenthesis and quotes I am giving last evaluation score. So irrespective of whichever commands you use and whenever you run them, you will get the same output here. So you can see that you have your title of the plot on the top left, you have last evaluation score versus satisfactory level, that is y versus x. On the y-axis I have last evaluation score, and on the x-axis I have satisfactory level. So this is how you add a description, that is a title to your plot, and a label or a description to your x and y axis. So now let's see how to save this plot to a current working directory. Now to save this plot to our current working directory, I am going to use the function ggsave. So you can save all the layers right from ggplot to geompoint to mentioning the title and x and y labels. And you can save all these layers under a variable name. Now I'm just calling that variable name as my plot, right? So once I just execute this, all the layers are saved under my plot. So we need to use the function ggsave to save this plot. Now the first input that you need to give is the name of the plot followed by the extension, and I am saving it as plot.png. You can check out the other extension that this function offers as well. The next parameter is plot. Now we need to know which plot are we going to save. So under plot I am just going to mention the plot that I want to save. I have called it my plot. Now width and height basically tell you what should be the width and the height of the plot while you are saving it. So once you export it as a plot, it fixes the width and the height and saves it correspondingly. And once you just run this command, you basically get your plot in your working directory. So now let's see how to introduce a third variable by color encoding them. Now here the points are color encoded using the variable left. So all the other layers are going to be the same. Only the highlighted layer is the part that will be changed. Now under geom_point function, I am going to use the function aesthetic represented by AES. Now instead of giving a color to the parameter call, so I am basically going to give a categorical variable to it. So based on the existing categories, it automatically assigns the color. So this is the output that you get. The shape of the points is again circle. The only difference is the color of the points, and that's because of the third variable, which is left. Now you can see that left basically has 2 levels, like I earlier said in the variable description. Now it has 0 and 1. 1 corresponds to people who have left and 0 corresponds to people who have stayed. People with high last evaluation score, but then they are unhappy with the company. So they are the people who have left. There's another chunk of people who have left. They basically have average satisfactory level about their company, and they also have average last evaluation score. So you can see that this is the other chunk which has left, and the third chunk that has left is on the extreme right. They are very happy about the company and they have a very high last evaluation score, but then they've still left. So this kind of visualization is very powerful because it can give you insights that you cannot otherwise get. So now let's see how to introduce a fourth variable by shape encoding them. Now this is in addition to the previous layer. So I'm going to use the variable promotion in last 5 years. This is again categorical. Now in addition to call equal to left, right, that is what I have mentioned earlier, I am going to put the shape as promotion in last 5 years. So all the other layers are going to be the same, and once you run this you will get the following output. So on the extreme right you will see the legends. Left is something we've already seen what it means, and the promotion in last 5 years is encoded as circles and triangle. So whenever you basically see a circle and you have red, then it means that they've not been promoted and they've stayed, and if the same circle is in blue, then it means that they've not been promoted and they've left. And similarly for triangle, triangle represent that they've been promoted in the last 5 years. So a red triangle basically represents that they've been promoted and they've not left, and a blue triangle basically represents that they've been promoted and then they've left. So this is how you introduce a fourth variable. In the normal plotting tool that R provides, this is not possible. You can at most introduce only a third variable, that is in terms of color. So in this lecture we saw how to generate scatter plots, how to change the color, size and shape of the points that are used in the scatter plot. What we also saw was how to add title and axis labels to these plots, and we saw how to introduce additional variables, that is a third and a fourth variable in terms of color and shape, to an existing scatter plot. Thank you.